Hello and welcome. We're going to go over some factoring details, why it's important, why we hate it, and also why it's actually everything we know about algebra in one process, and one, I guess, assignment process, a problem. You may get a single problem that is to factor some trinomial terms, and that's going to be everything you've learned in algebra up to that point. So my argument here is factoring is your gateway to being able to do all of mathematics. It's a great form, and I've done this with a lot of students in practice form. I've a whole summer dedicated to factoring and starting out with simple factors, simple polynomial, trinomial terms, going into more complicated ways to uh, obfuscate the process. And in the end, it really does resemble a form of lock picking, a form of trying to figure out how to undo the combination of this particular set of equations and finding their root values. That's generally the meaning of factoring, or the reason why we actually factor. But it's not the end result that's important. It's the process. So let's go over a couple of reasons why essentially, if you think about working out, going to the gym, working out your arms, right? What are you working out? You're working out your arms, your biceps, your triceps, your whatever ceps on your arms. I'm not a weightlifter, but there is a focus to those exercises, and it's specific to your arms. Your legs don't get a benefit. Then you go do any squats or any of the machines that focus on legs. Then what do? You refocus those particular types of exercises to those critical points that you're focusing on. Now, I like to basically look at factoring like swimming, exercising through swimming. Swimming requires every single muscle in the body to actually be exercised, used, exhausted. So swimming is the ultimate way you can fine tune every muscle in your body by doing one exercise. And in the same format, this is similar to factoring. Every part of logical, critical thinking, problem solving, manipulation of algebra, and using it to your advantage exists within just this one task to factor a trinomial. So let's swim a little bit with some simple factors and really get an idea of the overall. What you're seeing here is one of my exercises with some students. I introduced factoring as a very simplistic idea, right? Trying to figure out between 10x and 10x squared and 5x, what are the common pieces inside? Immediately, for some, you can see, well, 10 has a 5 in it, like in the multiplication sense, right? And 5 has a 5 in it. So we can use that to bring it out to the front. But break it into smaller pieces, smaller steps, we can really see what's happening right underneath where we start splitting our values. You can see for 10, we have smaller pieces underneath, like the 5 and 2 on the top. My hand's getting cut off here. The 5 and the 2 on the top create that 10. This is one of algebra's most prolific issues in the way we teach it. We teach math in a single directional format. We ask, hey, what's 2 times 5? 10. And then we're done. We don't think about it anymore. But we don't emphasize enough that an equal sign is bidirectional. It works both directions. We're just so used to putting two numbers into one, we're not thinking about splitting apart numbers into two. Of course, this is us splitting a 10 with multiplication as 2 times 5, but I can easily split it through addition as 5 plus 5 or 2 plus 8. It's really conditional and when we need certain of those techniques. Through factoring, we're essentially working with products and quotients. We're dividing, we're multiplying, we're trying to find basically the opposite of distribution. So our specific need is to focus on this. It's to focus on how do we get 10 from, or what combination of numbers can give us 10 if we split it in two. And another possible answer is 1 times 10. Straightforward. You can do that too. There's multiple ways to get to our final answers. And that's also important because that's where actually trying to figure out the combination of a quadratic is going to help the most. trying to figure out all the combinations to get that one number to split into two. All right, well, this is what happens here. Our 10 splits into 2 and 5. Our x squared, remember, multiplication of the same thing twice is a type of exponentiation. So 2 times 2 times 2 is going to be 2 to the third power. Another thing we don't think about. The first instinct for anyone is to actually multiply the numbers and get 8. But don't rush when you're doing factoring. You don't necessarily care for the final number that you're seeing, the 10 itself. The more useful way to look at 10 is 5 times 2. Why? Because then we can identify right here behind my head that this 5 and this 10 split. We have a 5 inside the 10. We also have a 5 right here. That is a common factor between these two terms. Terms, remember, split by plus or minus, whichever one is visible. So we have two terms. We see a 5 over there and a 5 here, but then we also notice x times x makes that square up there. Well, we can also see another x over here next to the 5. Identifying what common pieces exist within each term is the starting point, is how we start to factor, just as a basic sense, a very simplistic form of it. So what do we find out? We find out that 5x is what actually gets extracted out. It's the same thing in both. They both have a common of 5x, so we divide it to get rid of it. Remember your typical 5 divided by 5 is 1. X divided by x is 1. This is how we just get rid of it without changing anything. Those ones exist as a adjustment because of the division, but that division doesn't mean it goes away. It means it was pushed out to the front. In the same retrospect, what happens on the other side? Same thing. However, this is a common issue with students. They see 5 and 5 divide to 1. They see that x and x divide to 1, but they think of it as canceling, not dividing to 1. So what would happen? They forget to put the 1 right here. They just put 2x and they think that's the final piece because they are canceling. That's the initial act or habit that we have, maybe picked up from a bad teacher, maybe picked up from misunderstanding or mispronunciation of the idea. But remember, 5x divided by 5x is 1. So that has to be placed with the original sign plus that came from that location. So this is the final factored form. We took out 5x from the groups. Well, what is factoring but not distribution in reverse? What would then happen if I decided to reverse this process? Bring it back in. What's the bringing in? Well, it's that piece that separates the 5x from the parenthesis. Multiplication. So notice, whoop, that's a horrible multiply. It's a horrible way to spell multiply. Multi. Notice that we took out this factor to the front with division, but we can just as easily place that factor back in with multiplication. So what's going to happen? 5 times 2. Ain't that the 10? Huh? X times x. Ain't that the x squared? Factoring out is the reverse action of distribution. And of course, the same thing happens with the next part. We have a 5x over there in the front, multiplying by 1, and we still get our 5x there. So that's the key. This is the simplest form of factoring in a two-term grouping. But when we do quadratics in a bigger sense, we run into a whole set of how and what we have to actually do to find the best way of approach. Here's another quick example. Without all the separation, two numbers that give you 49, 7 times 7. Two numbers that give you 21, 7 times 3. You take out a 7 because we did say it twice. You get 7 out there, 7 out there, divide it out to the front. And then what's left? Well, 49 divided by 7, 3. 7. 21 divided by 7, 3. And also do the same for your x's, since there are two x's multiplying on the top, hence the square. There's 1 on the bottom. Similarly, 1 to 1 cancel, leaving 1 there. I didn't show the actual splits, but this is kind of where you have to imagine what's happening manually. The x's cancel, leaving one left. This one left ends up being the remainder in the parenthesis. Whatever leaves and divides goes to the very front. Whatever stays in blue and doesn't cancel or doesn't go to 1, divide to 1, stays inside of the parenthesis. And that's the consideration to go for. So what happens here? Same idea. There's that same idea for factoring and distribution. Factoring is how we take stuff out in red. Distribution is how we bring it back in. There is a type of two-directional process we do, or a direction. Sometimes we like to factor to find something out about the equation. Other times we simplify just to provide a overall look of what equation we're working with or how it's supposed to look like highest powers. So now we enter group factoring. This is a tough subject because the obfuscation of shortcuts is very, very prominent in the public school system. They try to teach you all these shortcuts of how to do this and just put two parentheses and then fill them in like this, right? Find out what your A and C is, find out a number to get that, and then split it into these two locations. Boom and boom, number and number. And put the two parentheses, set yourself up, put the x's in the front. Great, all right, fine. This only works when x is 1, by the way. The shortcuts work under specific conditions. So what happens when we're given these shortcuts? Sure, it might make some problems easier, but now we have to identify when to use the shortcuts, a layer on top of complexity. Why not just have one way to solve all of them? Sometimes it may be a little extra work, sure, but at least you'll get to the answer, especially when you practice these and you go quick. It doesn't matter how many seconds you save here and there. But you don't have to qualify whether you have the correct type of quadratic to do a specific shortcut. There is a one way to do them all. And that way is just straight up AC method and group factor. This is how it's laid out. AC method requires the A and the C of our quadratic. I'll probably go a little quick here, but we will go through a lot of practice in the future. I already have some practice that we do on the channel. So find those in the mathematics section playlist. I'll link in the description below. But there are ways you can literally look already now that I have plenty of examples. And make sure to like and subscribe when we do live examples, because then you can actually pose your questions directly. And like they all say, if you have a question about something, there's a guarantee somebody else has that same question. So make sure to ask during our live streams, join in, chat, communicate, and then also leave a comment. What do you think about this explanation? Does it make sense to you? Is it too quick? Is it too slow? Is it too much? All of those are valid, and make sure you have your voice heard in the comment section below. So here's our equation. Ax, or well, x squared plus 5x plus c. The first piece is to realize the alignment of our general equation of ax squared bx plus c. General, meaning it's all going to look like this in some format. It's like a template. We have a, which is in front of x squared, a very common issue. When there's nothing in front of x squared, there is an invisible 1. That's why I made it manifest in green. So always remember what is in front of x squared. A, that's the A. Some students will say, oh, A is x squared, isn't it? Not the same, because x squared is already in the template. So why are we associating a totally different value, with the x squared already shown? So the real idea is don't try to focus on the terms and the way that they are organized, or the letters specifically, but rather the variables that make the most sense, that we see the most, which are x squared and x, and then no x at all. The a, b, and c, those are just position placements. A is in front of x squared, so whatever is in front of x squared is a, aka the 1. Whatever is in front of x is b, and b is our 5. And then finally, wherever is the kind of dangling side addition constant with no x, there's c, 6. Identifying these three first brings us to the next steps of finding our AC. There is the situation that we had before with the 10. What are ways we can split 10 into multiplication? 2 and 5, right? Now it's 6. There's 2 ways we can do that. 1 times 6, which is 6, and 2 times 3. which is also 6. Now, the check here is specific to not only making sure we get the right product pieces for that AC valuation. And remember, A and C are always going to be multiplied because what is the A and C method telling you? You take A and you multiply the C. That little space in between, when there's nothing in between variables, that's multiplication, even in the title. So A times C method. So we take an A times C, a 1 times 6, and we can also find a 3 times 2. That's the first layout. Give me all the combinations I can find. Then we check using addition. Those numbers that would normally multiply to give us 6, we're checking through addition to see if we get 5, the B, the middle that we saw earlier. So one of these will give us the 5. This is the hunt for the combination. What combination gives us a 6 when we multiply and a 5 when we add? And that's going to be 2 times 3. 6 times 1 gives us a 7. Not relative. We don't have a 7 in the middle. It's all based on lock picking, or really like safe cracking, trying to find the right numbers that fit this safe particularly. We needed the 1 times 6 from the outsides, right? The outsides. And then they together try to work their way into the 5. So the 1 and the 6 multiplied to 6, and then what combination of 1 and 6 added give you the middle. This is how we fine-tune the numbers that we will use in the next step, which is group factoring. So once we find it, we go to step 2. We find a combo to get B with addition. Then step 3, split B into the found combination and group factor. Well, where is our B? This was the purple. There's our B, just kind of reiterating it from the above to the actual group factoring space. We split B into 2 and 3. The 2 and 3 we found here. So 2 plus 3 makes our 5. Not only that, we have to make sure term is correct. It is a 5x, so we got to give the 2 and the 3 an x to maintain that term, like term perspective. From there, we split the two groupings because we have group factoring at this point. We want to divide and conquer. We don't want to look at the whole equation as one, but rather split it down the middle and start thinking about two groupings individually factoring over there and then individually factoring here. With that, we take what is common, just like we did in the very first part of this video. What is common between x squared and 2x? Turns out that it's x. We divide that x to the front. Divided x, divided x. There it is in the front now. Boom. Same thing on the other side, between 3x and 6. Well, smaller numbers, nothing like the 49 we did earlier, but 3 has a common with 6, another 3. So we can divide both by 3, bring out the 3 to the front. And boom. With that, we have the first layer of group factoring. We take both of those pieces, take them to the front, the 3 in the front here, and the x in the front over there. Then becomes the tricky part. This is what everyone overlooks. When we factor stuff, we're so focused on just finding one thing they have in common. Just a 7 inside of a 49, or a 7 inside of a 21. But we don't consider that copies are copies no matter what. The next step is actually identifying a grouping of copy and pastes. Thinking about that middle, again, separating the two sides. On this side, we have an x plus 2 in common with that side, an x plus 2. Same thing that we've done before. Just like the 3, just like the x, we divide them out, bring them to the front. Let me repeat that. Don't just focus on the single digits that might be in common through factoring. Groups can also be in common, right? Over here, we kind of had to split down this middle and we were focusing on this side and this side, trying to see which these two splits have in common. But when we leave and we do our very first factoring of our 3 and x, we now focus on the red line being the split. And now our two sides are much bigger and also contain much bigger groupings. So x plus 2 and x plus 2, as well as another x plus 2 over here. Divide it out, bring it to the front. What's the leftover? Well, same thing, x plus 2 divided by same thing, x plus 2, 1. It's got exact same copies, top and bottom. Doesn't matter how complicated they look. If they're the exact same things dividing, there's 1. That's it. Same thing here. No matter how complicated they look, if they're the exact same copies, they're a 1. What's the remainder? Well, that 3, kind of change the colors here, the color scheme a little bit different. That 3 comes to the, stays remainder, right? Remaining after we divide out the x plus 2, it goes away. And then the x over here, over there, I'm gonna cut off over there. The x, the red x in the front is now this x here. So not only do we take out the grouping that we divided, the x plus 2, from the bottoms here, in the same way we've been doing common factors, but we also take out the remaining x and 3 and the plus. There's a plus in front of that 3, which also maintains its location. And then finally, we have our group factor, or our final factor, our quadratic factor, if you will. In the same way, we can double check our process by doing distribution. What's distribution between two groupings with two terms inside? Foiling. That's the check. That's it. And remember, foiling. It's going to be important too. A lot of students I see that don't really get it, and I didn't get it for a while too, or at least what order. I always forgot certain things that would need to be multiplied. But the idea is just multiply all possible combinations without duplicates. So the x with the x, and then x again with the 3x. Once you do those two combinations, move to the next term. The 2 with the x, another combo, and then a 2 with the 3. And then once we do all combinations with that 2, we're done. There's no more terms to go for. And then look at that. We work our way back, and we'll notice that we find the original above. Another proof to the pudding that there is a two-directional process. Factoring is the reverse of distribution. Two-term, two-grouping distribution is just foiling in the way that it looks. There's also three-term, two-group distributions, but we'll get to those in the future for the more complex versions. So that's what I want to leave you with. This incorporates a lot of stuff. Incorporates the fact that we're splitting 5 into a +2 and a +3. Remember, we can split numbers. We're so used to seeing two numbers become 1, we don't think about the reverse. A 5 can become 2 numbers when it's useful for us. And when is it useful for us? When we critically think the perfect combination we need to factor. Right? Critical thinking is the development of using these tools. As you do more of these, and this is an easy one, but as you do more of these, you gain a higher level of critical thinking and troubleshooting. How and what numbers and how I can find all the numbers and then what combinations. That's critical thinking. It's figuring out how to get a solution from a mixture of blah. So these are great practice. I recommend anyone going through, even starting, like when you first start doing factoring, burn yourself out doing these. This will fortify every single algebra that you have in your head and show you all the details about how just algebra works, how PEMDAS works. This is why I always bring up PEMDAS in the end. PEMDAS is the absolute ultimate guide here. When we take addition and we lay it out in pluses of the same number, well, mathematicians are lazy. We just say 2 times 5. What do I want to say? 2 plus 2 plus 2 plus 2 plus 2. The same thing, right? Oh, but there's also a connection with multiplication. When I have 2 times 2 times 2 times 2, why would I want to write so much? 2 to the fourth power. These are connections between PEMDAS that aren't very often shown, but I like to always show them to all my students. So this is kind of the main idea. Practice these, follow, subscribe, and we will do plenty of these in our brain training sessions to basically fortify this. I will, if we get a good little audience going on out there, I will let you guys lead. You will tell me what I need to do, just like I do in my sessions. What the first step is, what the second step is, what numbers we can use, and from there, we'll make our community continually train together as a group. So that's my goal. My goal is to bring up and really inspire those that are ready to start truly expanding their thoughts and their brains and just working out their brain muscles, man. Because the brain muscle is the same thing as a regular muscle. It functions slightly different. It doesn't pick stuff up, but it does process and pick up ideas. The less you do these kind of trainings, and this is also a fact, the more you outsource your thinking to a television, to an AI, to a calculator, the faster that person can develop Alzheimer's and forgetting things and not having the optimum brain power necessary. Because the body works in the form of use. The body evolves with the form of use. If you use something consistently and your body notices they need to be constantly growing that sector of your biology, the body will continue to make it stronger. If you neglect it and never use it again, just like Arnold Schwarzenegger's muscles, they become big flabs of fat. Keep that in mind. The muscle on your arm that you use to lift things will get bigger when you train it. And the muscle in your brain will get smarter when you practice and develop it. So join me, subscribe, like, leave your comments, and join me for next lives. And let's go ahead. Let's practice that. Let's motivate a collective brain training process here. Because I'm kind of tired of seeing AI take over. I'm kind of tired of seeing people not being able to think and communicate correctly. All the aggression and all the chaos. People just, when they have no ability to respond, no ability to think around the things they're going through, aggression comes up. It's just human nature. So let's get critical. Let's get training. Join you in the next live. Ask you questions and leave a comment below. Also, I do private tutoring. So check me out on Patreon. You can do just a regular free membership just to get in communication with me. Or if you do generally need any help with mathematics, programming, statistical analysis, I even do financial data stuff, feel free to join any of those memberships and I'll be able to help you either indirectly with messages and videos or directly as a one-to-one 1 hour session with you, and you can ask any question you want and we'll go over those details together. So thanks for joining. I appreciate any and all of you that made it to this end. It is math. I am a teacher. I understand the implications of trying to make educational content with a world full of 15-second TikTok and shorts of slop. But I hope you can join me to stopping this slop because it's getting overwhelming, guys. It's really getting overwhelming. Um, we need to pick ourselves up as a humanity, as a race that has survived for thousands of years. We can't just let it all go to waste now. All those working human beings to keep us safe from bears and starvation to just now becoming brain slop and AI. It's sad, but join me. Thanks for joining. Thanks for watching. Thanks for making it to this far. If you have, my can't think about the words I'm saying anymore. But bye. I'll see you next time.